Okay, before our esteemed Vice President learned about X-rays and that the X-ray techs do it in the dark, he had another life in the audio-visual world. The degree's actually in photography.
Illustrative and advertising photography.
Illustrating and advertising photography. So he's going to tell us about audio and what all these fancy sliders and switches and all this stuff on the mixer boards that you see do. So without further ado, Rick Cobb, N4XYY.
Thank you very much. All right, well, I'm going to get up here and hide a little bit. I'll try not to hide too much. Like Mike said, I worked in audio back in the day when we had real tape and did editing with a razor blade and tape. I'm serious. It worked. But I didn't know who Bob Howe was until 6 or 8 years ago. But as I've seen some of his videos and some of his presentations, you're going to see some of the similar presentations here. A little bit of it I got from him, but a lot of it, it's all the same that applies across the audio world in general, except that when the audio world that we live in is generally in a much narrower bandwidth than full broadcast or stereo quality audio, CD quality we call it today. So it's a little more limited. But here, you may have seen part of this presentation a few years ago when I did it. I have cut out a lot of the fluff. I'm not going to bore you with a lot of stuff. I'm going to try to get through this quickly, and then I'll go through a little demo of what I got set up down here. I've got some recordings from the 40 meter band, and I'm going to try to demo, kind of like Bob Howe did on his YouTube, what the equalization can do to help you hear. Well, let's just get started here and see what these slides say. Yeah, turn your voice into electrons, preparing your sound for the radio, getting sound into the rig, getting sound out of the rig, molding sound for intelligibility, and getting sound to your ears, and the nitty-gritty about mixers, and that's what I'm going to concentrate on tonight is mixers. If you want one in your shack, if you dreamed of having a mixer, do you really need one, do you not? Let's see here. We'll start with microphones. It's a device to convert sound waves into electrical energy. Hey, you know, this mic here, but I like using this one anyway. It's a better mic, it's a Shure mic. SM58. This mic's been around for a long time. And you can see one here. Hand mics, little Kenwood stand mic there, I believe, and an old-fashioned studio kind of mic. There's several different kinds of microphones. The very first kind that grew with any popularity pretty much was invented by the phone company. Am I loud enough? Can you hear me?
Yeah, we could use more.
You could use a tweak more.
Yes.
First microphones were carbon granules in a little cartridge. Believe it or not, the sound flowing through those granules of carbon between two electrical plates generated electrical energy, enough electrical energy to send way down a phone line. You didn't even need a preamp or an amplifier. You could send it for miles without having amplification of any sort. They didn't have amplifiers when they first started doing phones. They were wired straight up to the keyboard, to the switchboard, and the operator would connect two together, and you'd be talking into your little carbon mic into somebody else's receiver. There are some examples, the old candlestick phone, and there's an old WSB mic, and that's the carbon mic right there that you see in the old telephone receivers. I used to do teleconference work for Bell South, and when you get somebody on the phone on the other end, they sound terrible. They're scratchy and gnarly. You can tell them, take the end of the telephone, whack it on the desk a couple times, and it clears up perfectly and redistributes the carbon. Condenser microphone. And, I didn't think about it before. What does condenser mean? Well, we used to call capacitors condensers. It is a capacitor, a variable capacitor, developed by Bell Labs, low output, made practical by the measure of the vacuum tube, moving and stationary plate forming a capacitor, and it requires a polarized voltage applied to the plates to activate it, and we call that phantom power. There it is in great detail, but generates a low signal, a microphone level signal. Here are a few examples, old studio type mic. This is a modern day studio condenser that you'll find in a recording studio, and that's an old ham radio mic. You don't see many condensers for ham radios these days, partly because it does require the phantom power to make it work. Most of them are omnidirectional, which is not great for the ham shack. Then we go to the dynamic microphone. That's one of the most popular microphones today. This is a dynamic mic. Most of Bob Heil's line, they're all dynamic microphones. It's literally a speaker turned backwards. These sound waves push the cone, or the diaphragm as it's called here, and the diaphragm's attached to a coil of wire, and a coil of wire is wrapped around a magnet, and it literally generates an electrical energy, positive and negative, as it comes in and out. And that's how it works. They're very, as the note said there, they're very rugged. They can extend moisture, high sound levels. Drop the mic thing. Boom. Couldn't do that with a condenser. Here's some examples of the dynamic, the PR781, great mic. The Shure SM58, as we mentioned. There's no Cobra, a hand mic. You don't see many dynamic mics in the hand mics. In the hand mics, what you usually find is an electret microphone. And this is a form of a condenser microphone. And it's got two plates, but one of the plates is actually attached to the substrate of a semiconductor device, which forms a transistor. And you can see that one side's positive, the other side's negative. You find these in almost all ham radio hand mics. You find a dozen of them in your cell phone. They're dirt cheap to manufacture. They're pretty high quality when they're made right. So they're very popular. They're usually omnidirectional. So they're going to pick up sound from all the way around you. Here's another mic you probably never see in ham radio field, and that's called a ribbon mic. You see them high-end mics, I'm talking $2,000–3,000 microphones in recording studios. They consist of a thin foil, corrugated piece of foil, suspended between two magnets, which generates a electrical current put through a step-up transformer, which is usually in the microphone itself. Like I said, they're very sensitive, very expensive, and one good bop on the side, and they're shot. They have to be rebuilt. And these high-end $1,000+ microphones, they do rebuild them. They put new elements in. Here are the microphone patterns, and that look like familiar patterns. Looks just like an antenna pattern. Huh? They are very much like an antenna pattern. The omnidirectional, all directions. It actually forms a globe around the microphone. It's not just around that way. It's all over. Like you put a basketball around it. That's what the pattern looks like. Then there's the cardioid. This mic is a cardioid mic, and you don't see this much in antennas. Maybe a parabolic antenna would act somewhat like a cardioid, because you see at the very end there is a complete 100%, pretty much 100% rejection, and that's very useful. So I can turn this mic around in the back, not picking up a single bit of sound from me until I turn it back to me. That's great on stage, because when you got a lot of speakers blowing in the background, you got a studio monitor sitting on the stage loud enough that a person can hear themselves talk and sing. But as long as that mic is pointed at that speaker, no feedback, works great. You get into even more directional mics, and they begin to develop a lobe, just like a directional antenna. The more directional they try to make them, the worse the back lobe gets until they turn into a figure 8. And figure 8 is popular in studio recordings because they like it. It picks up the person very present in front of the mic, and it gives a little resonance behind it for the rest of the room without encompassing the entire room, picking up a lot of noise you don't want. That's an example of an omnidirectional mic with an electret element. And a cardioid pattern, the Heil PR781's cardioid, just like this one. And a shotgun mic, which you see used a lot in video and motion picture production, extremely directional. You can see they've got a pretty bad lobe in the back though. You see them hanging way up above the actors. I mean, they'll hold them 3-4 feet above so they're not in the picture, but they're directional enough it sounds like the mic's right on them. Trouble is if an airplane goes across the back of them, they got to reshoot because that back lobe picked it up. And finally there's noise canceling microphones. These are usually an electret element. They're fitted in a housing, and you find these in headsets, especially headsets that are used in aircraft and high noise environments. They are fitted in such a way, there's little holes in the back of this chamber, and the sound that makes it through these holes in the back is delayed just enough that they cancel out the noise. It's difficult to explain, but it works. You'll find a second mic on almost all cell phones, and that mic is there to help reduce noise. It's reversed in polarity from the main mic that you're speaking into, so it's picking up noise all around you, canceling it in the signal, so your voice sounds better. Most mics require preamplifier, almost all mics. Some amateur receivers have them built in. Some of the transceivers provide power, most of them provide power, so you could power an electret mic. It's usually not enough power to power a cardioid mic, a condenser mic. For a condenser mic, you'd really need a preamp that had enough power to make that mic work. So the early ICOM pre-Pro models had a preamp in the microphone. So actually, Bob Howell makes a special set of microphones for those older radios that have a higher output, because if you swap the mic out, you swap the preamp out. You've got no preamp going to the radio. You need to up the signal. There's probably a homebrew little 1-2 preamp. Now, who wants a mixer in their shack? Here we go. What if your shack looks like that? Man, wouldn't that be fun? You can sit there turning knobs all day long. Well, that's not what it's going to look like. Why do I need or want a mixer? One thing right off I found was, well, I got 2 radios, but I only have one good microphone on a stand, and I don't want to be switching back and forth. I don't want to switch boxes. Some of those things cost $100 just to switch your mic back and forth. That's crazy. I can make my own, but a mixer allows you to have one mic connected and feed 2 radios. If the mixer has enough channels, you can feed the audio out of the radios into some speakers or headphones. Or you can add a computer to the mix and send audio to and from the computer. Why would I want to send audio to and from the computer? So I can work digital. I can route the signals from the computer back to the radio, and from the radio back to the PC. Now that, of course, doesn't handle keying. You got to do that some other way, either Vox or come up with it with your own keying method to make that work. Here's a simple stereo mixer. It's got 2 channels, left and right. Or in some circles we call them buses, but this would be considered a single bus mixer, because when you say bus in the audio world, you generally always mean it's a stereo bus. It's got 2 channels. And so you can see we got the mic connected to the left side, and it's feeding this radio, and it's feeding that radio. And we only have the mic set to come out of the left channel. I would take the audio out of one rig and another rig and feed the right channel. And we can take a very small and simple mixer with just a few channels, inexpensive, and feed speakers and headset. So that's a nice way kind of to get started. If you want to go with a very basic method. What did I do wrong? Oh, went too far. We could step up to a 2-bus mixer. A 2-bus mixer means it's got a main out left and right, and then it's got a couple auxiliary outs left and right. And now we've got a lot more flexibility. We can take the mic and feed it into left and right channels on this main mix bus, and that can feed this radio, and you can feed into your computer. You can feed into any number of radios you wanted to feed it to, really, as long as you got channels coming out of the mixer. And then you use your sub-bus. Now you can take audio out of your rig and feed it into the sub-bus. And actually, the TS2000 has 2 audio outputs. It's got a main receiver, main transceiver, and a secondary transceiver. So you can listen to 2 frequencies at the same time. And with this setup, I've heard people ask me, well, how do I get one radio to come out of one speaker and the other out of the other? Well, that's very easy in a mixer. You just what they call pan one to the left, pan one to the right. You might have a third radio. You can pan it to the middle. If you got an expansive shack, you've already spent thousands of dollars on these rigs, a couple $100 more for a mixer, and you can do a lot easier job of using them all. You don't have to have multiple microphones. You don't have to have multiple speakers. You can concentrate on having one good set of speakers that sound really great, and you can mold that sound to sound good. Here are a couple of mixers. Hope I'm not moving too fast. I feel like I'm going a mile a minute. Let's start at the bottom end. Now, you can find them cheaper than $50. I'm concentrating on Behringer tonight because I'm somewhat familiar with their line, and they've got a good lineup of almost anything you could possibly want. It's a Chinese company, but it was started by, I think it was a German-American. He decided to move to China, and he learned how manufacturing worked in China, built a plant, and started building audio gear at a professional level at a much greater price point. And so that makes them very suitable for the ham radio field. This is a very, very basic mixer here. Like I said, $50. This one has a USB, so you can plug this into your computer. And actually, your computer powers it. It doesn't have an extra power jack. And that USB can be used, again, to use your computer to put audio to the computer or get audio from the computer. You only take one mic, and I know you can't see it back there, but it only has a low and a high equalization, or tone control, we would call it. Now, in amateur radio world, really, on a single sideband, the bandwidth's going to be from 1.9 kilohertz to 2.4. This bass control centered around 800 to 100 hertz, and the trebles centered around 1200 kilohertz. That means that they're really not going to do a darn thing. And Bob Howell talks about this in his videos. If you're trying to contour your speech, your microphone, it's not going to do anything. It's outside the bandpass of single sideband. What you would do, and most modern rigs have some little bit of equalization and compression capabilities built in. Just use the rig. What you want to use here, this is just for the convenience of maybe feeding 2 radios with one mic and having the capability of the mic having a USB to computer interface. We can step up just a little bit, and now we've got a lot more to play with. This has more channels. It still is only a single bus stereo mixer. It has a left and a right, and that's all it does. So you end up using, if you want to use it the Bob Howell way, use left to feed your speakers and use right, or left to feed the radio and right to feed the speaker. You're not going to have stereo, but I don't know if anybody here is broadcasting amateur radio and stereo. But this is a nifty little mixer, and it's only $60. It's got neat little level meters here, so you can actually see, unlike most radios. Now, sideband radios, we can see deflection in ALC, and that's great. One big beef I've always had is that on FM radios, you have no idea what your audio level really like. You know, old cheap Radio Shack tape recorders used to have a peak light, so you could tell if you were talking loud enough or too loud. I don't know why they don't put those on FM radios, because you know you hear folks talking like this, going down the road noise, and some people are like this, and it just doesn't matter. So anyway, pet peeve of mine.
Mine too.
We can step up $20 more, and we can add USB. And oh, one thing I forgot to mention: both of these two mixers have a mid-range control. Now that's the important part, and I'm going to try to demo this for you a little later. That's the important part on raising that mid-range. It's around 2.5 to 3 kilohertz to get that sound into your ear and make it discernible. I just got a brand new set of hearing aids yesterday, and they're great. I can hear everybody, and I'm really hearing myself loud too, so that's why I can't really judge if I'm speaking loud enough or not. But I thought it was interesting, and I meant to throw in a slide with this. Something I discovered a few days ago is your ear canal has a resonant frequency, and normal male at the body temperature is around 2.5 to 2.7 kilohertz, which is interesting because it's right there in the speech area, which helps us to hear voices. Women's voices and children's voices are a little higher, and that's why we don't hear them sometimes.
That's his excuse.
Sorry.
There needs to be a bumper sticker.
But when he put them in my ear, then he hooked this other device up and put a speaker in front of me, and it ran a sweep tone. I could hear it. And it's the same kind of sweep tone that we use in an auditorium when we want to set the equalization. And what he was doing is he was checking how these devices that he plugged into my ears changed the resonant frequency of my ear canal. So he adjusted the EQ. I've got a higher end DSP in my ear than I do down here, and 3 or 4 times, 5 or 6 times more expensive too.
Yeah.
But yeah, this mixer has many more channels. This is why, if I wanted a beginner's mixer, I'd jump into this. And if you're really into USB, pop another $20 in it, and you got a USB interface. And this you could use as your digital interface, in and out. Now, if you want to go up to a level that I see in many ham shacks, some of the YouTubes and things I've watched about people that are into this audio thing and wanting a mixer, they jump up to a mixer that has 2 buses. And like I showed you before, you can do all your microphone work on one bus, completely independent of what your speaker buses are. You can also play stereo music off of your computer. Because I do that sometimes when I'm sitting in the shack. I'll sit and listen to a podcast or something, and on the same speakers that I listen to my radio on. I can even have the radio on squelched and waiting for FM to start or something. So, and it has the same mid-range equalization. This also offers you a little bit of compression. So if you want to do some compression, not in the radio, you can do a little bit of compression at the mixer level. About $150. Yeah.
Hey Rick,
Yes, sir.
would the compression at the mixer, built into the mixer, be any better than what's built into a lot of radios?
It's debatable. It might be easier because it's just a knob right there in front of you, whereas the rig, you might have to go into a menu and go through, what is it, 1, 5, 6, 7, 8. A lot easier to adjust. So, one way or the other.
Really, is it really more limiting rather than compressing?
Well, no, it's a true logarithmic limiter.
Okay.
Well, a logarithmic limiter basically is a compressor.
Roger
A
that.
limiter basically means that the audio gets up to a certain level and it won't let it go any higher, but it still gets up there just as loudly.
Right.
It clips.
Yeah, it cuts it out. They're soft limiters. Usually none of them
Yeah, it's
do a hard
not
cut.
a real hard clip.
But they stop you before you get beyond over a maximum range.
Right.
A compressor does this logarithmically over the entire level.
Right.
So as you get a little higher, it adds a little more limiting. Get a little higher, it adds a little more limiting, a little more limiting. Why do we want to do that? It seems like you're reducing your audio output. Well, you are. Overall, you're reducing your audio output. You're compressing it into a tighter band. And then you crank the gain up. And it comes back up to full gain, which would be the full gain, so you're just barely deflecting ALC on a single sideband. But overall, RMS-wise, average power output is increased. Now, it sounds awful. It's not something you want to listen to. And we've had discussions about compressed music before. Highly compressed music these days, and it's done a lot and overdone, we think. Sounds awful, but that's not what you're looking for when you work in DX. You're looking for getting as much power on band as you can and hitting it as hard and in the frequency range that's going to hurt their ears when you say CQ or when you put out your call sign. And please, if you buy one of these things, buy a stand. I've watched these YouTubes, and the guy's got this great mixer sitting on his desk, and he's constantly doing this. He's looking up on top, because the mixer's designed to be looked down on. Some of the professional mixers, you can see, they built consoles that raise them up. Get you a little $20 laptop stand. Whoop, pop that thing up on it, it's the greatest thing in the world. And now, for the big step up, I call this the SDR mixers. Now, I have another model of this similar mixer here. This mixer's crazy capabilities. And it's nothing more than a little 2U, I believe that is, rack mount. It's not even a full 19 wide. It comes with little adapters if you want to mount it on a rack. Got 12 inputs. It has a main bus and an auxiliary bus. It does not provide a USB interface to your computer. It does have a USB port right there, you see. It actually is just for recording and playing back audio. It has an Ethernet, and it has built-in Wi-Fi. Not just a Wi-Fi client, but it's a Wi-Fi router. I have this one set as a Wi-Fi access point. If you brought up your phone, you'll see a source that starts with X18. You can connect to it. I don't even have a password on it. You can connect to it. You can't do anything unless you download the XAir app, which is a small app. It's easy to download. But $250 now. Oh, here's a lot of money. And I wouldn't advise this to the raw amateur that's never gotten into audio, because there's a learning curve. I think you open up the interface, and I'll show it to you in a little bit, and you'll be kind of going, wow, there's a lot of things I can set. You can set anything. You can do special effects. You can do compression, limiting, equalization. It's daunting what all you can do, but it will let you do anything and everything. Pardon? Flanging? Yes, yep. There's a flange, there's all sorts of little special effects things which you would never use on amateur radio. But they're there to impress your friends. But it is very flexible. If you've got a lot of radios, a lot of microphones, a big setup, this is something you'd want to go. You would add this along with your multiple automatic antenna switcher. But I like it a lot. And for $250, they were $300 when they came out. They came down to $250. I had bought just a regular analog mixer that cost me $300, and it didn't do half of what this did. Now, you think, well, it's a lot of money, I'm not going to mess with that. I'm going to buy one of these W2IHY boxes that are made for ham radio, and they are made for ham radio. The equalization here is what we call a graphic equalizer. We've got several bands of equalizations we can raise and lower. And we got all kinds of fancy knobs and compression and delays and output levels, monitor levels, all kinds of stuff. Well, this little box is $300. This one's $400. You know, they do what they're designed to do. They're custom built, and that's why they're so expensive. But you can do the same, and if not a lot more, with this little guy. A lot more than you can do with both of these boxes together once you've got over that learning curve. So if you're really interested in doing this kind of stuff, I'd skip this and I'd do that. I've tried to find a good graphical representation of compression. This is a single sideband signal that's been compressed. This is a normal signal, but you can see this one is compressed. It's been squeezed top to bottom like a sponge, but then the whole thing has been squeezed logarithmically, but stretched linearly, if that makes any sense. But you can see overall, if this was a container and you poured water in it, it would hold a lot more water. In other words, that's a lot more power on the air. It's punching out the full 100 watts, or maybe right in there you're punching out 75 watts or so in that little area right there, and peaking at 100. So it's putting more power on the airwaves. That's what compression is all about. Perceived, increase the perceived loudness. That's the key word there. Now, how do you get it all hooked up? There's all kinds of different connections. This is something you'll see in the professional audio world. It's been around a long time. It's called an XLR. And then more commonly, you see this is a phone jack. Technically, the telephone jack is this. What the old keyboard jacks. This is what they look like. Slightly different, but this is still, we call these phone jacks. And this is a balanced. Now, I think we all should know at this point the difference in a balanced and an unbalanced antenna. Well, it's the same pretty much darn thing with audio. You've got on a balanced, you've got like a hot and a cold, or a positive and a negative, however you want to look at it. And then you got a ground just for shield. This part carries no signal. It's just connected to the shield on the wire to keep noise out. 3 pins here, 3 pins here. Unbalanced connectors, just like coax. You got a center conductor and a ground. They both carry the electrical current. Same with the little RCA connector. The trouble is you don't see any of these on the back of a darn radio. You do on some older rigs have them, but the modern rigs now you're going to run into this aux 14 or 16 pin connector. So here's when you have to build yourself an interface box. This is what this is. And I've shown this before. Get it all hung up here. This is an interface box for my TIS-2000. As I said, the TIS-2000 has 2 outputs, a main out and a sub out. I've got a microphone in here, and I've got an input for digital, because Kenwoods have a separate microphone input for digital signal. When you key, and as they have a separate push to talk that keys and activates this without activating the microphone. And in the back you'll see a plug for a push to talk, which I have my handy foot switch plugged into, and you have a key in. Well, I don't have a key in here. Well, also in this box, I have a CW and RIDI interface, which is just a plain old USB interface. Not USB, excuse me, plain old serial. And by keying like a DTR and CTS, it activates a optical isolator in the box, and it actually keys the rig. You have keys in either for RIDI, keys it for CW, or keys it for digital. 3 different signals that come in through that are keyed through this port. And I've got isolation transformers in there. You don't necessarily always need an isolation transformer. Everybody thinks you do.
You don't necessarily need them. 9 times out of 10, probably or more times than that, you can end up plugging one device into another and never get a hum, never get RF. But everybody builds the isolation transformers into their interfaces, so that's fine. Now, quick, take this down so you'll have all this information for you. This is the different ways you can wire one connector to another. It's absurd, but if you ever trying to connect a phone balanced to a phone unbalanced, or an XLR to a XLR, a phone unbalanced, Google it. You'll find a chart like this and it'll tell you how to wire it up. That's all I'm going to say about that. I hand make all my cables. I'm a glutton for punishment, but I like to get them the right length, and I like to use the metal connectors with the spring strain relief, so that's just the way I roll. The right way to go from balanced to unbalanced is balance, right? That's basically what this is. It's just it's a balancing transformer. We've got a balanced input here with a separate ground feeding through a transformer. You have no electrical connection between these two grounds. That's why we call it isolated. So there's no chance of getting a hum or any problems in differential between the two chassis or whatever these grounds are connected to. Coming out to an unbalanced, which might be an RCA jack, just like you have on your stereo. Same way with unbalanced, feeding a balanced input. And here are some of the actual transformers that you would find to do it. You can get them through Mauser, all kinds of different transformers. You can buy a little box like this. This is called a direct box. This is used by the recording industry. You'll see them on stage. We got varying equipment. This is particularly important when you got the mixing boards in the back of the room and you got a mile of cable run up here, and then you got all your instruments plugged up here. They're plugged into different AC jacks for sure. And it's going to be a buzz, guaranteed. So you always use this direct box. About 20 bucks. This one does 2 channels. Does the exact same thing as audio isolator does. And you can use one as an audio isolator. They're kind of big and bulky. They just have little transformers in them like this. This is a commercially available transformer that's used a lot in PA systems. This is what I have in my little box. You can pick these up surplus for 10, 15 bucks. The nice thing about these is you can use it to isolate a balanced to an unbalanced, a balanced to balanced, unbalanced to unbalanced, or you can go balanced or unbalanced to microphone level. It's a switchblade. Just depends on how you wire it. One little transformer, and these are push terminals, looks like. The ones I have are screw terminals. They come in all different flavors. And getting speaker level audio out can be a problem. Oftentimes you can take the speaker out of the radio, turn the level about mid-range, and you can feed the input of a mixer because the mixer has pads built in, so you can pad down the level. But if you're trying to feed something that doesn't have a built-in pad, you're going to have to build something like this. And this is just a dropping network. You should recognize that. I think that's even in the first license exam, isn't it? just a basic voltage dropping network that will get you line out. Here's some of the speakers you see in amateur radio. And you may own one of these, you may own one of these. This one probably sounds better than either one of these.
Right.
You hear Bob Howell yakking about it all the time. You know, don't go buy a $200 or $300 speaker to match your radio. It's still not a great speaker. What? Yes, sir.
How much voltage do you usually have on the line? You talk about the line.
Line level usually runs a volt to 3 volts peak to peak, depending on what you come out of. Professional gear is about 3 volts peak to peak.
What is it, 600 volts?
It's really not 600 ohms, more like 1K usually. You know, like you hear Bob Howell yakking all the time. Don't buy these speakers. Yeah, they got a couple of little
tone controls here, roll off the bass, triple or whatever. But it's a fancy box with a cheap speaker in it. That's really what it is. I saw a kit on the internet the other day. Somebody was selling kits that you can replace this with a higher quality woofer and comes with insulation, because I don't even think the boxes have insulation in the back. You can upgrade these and make them sound somewhat better. But, think about it before you drop a couple $100 on a matching speaker for your rig. Instead, buy some of these. These are great. And I found this before Bob Howe did. I was ticked off when I started seeing the Bob Howe stuff. I did all my research. I guess I'm an AV guy, and I went to the Guitar Center in Sweetwater, and I looked at all the, quote, what they call near-field monitor. A near-field monitor is just a fancy word for saying it's a small bookshelf speaker that's made to sit pretty close. It's not something you put up on a shelf in your living room. It's something that's designed to sit on a desk or on a shelf right in front of you. And you need a powered one if you're going to use a mixer. And because the output of most radios is 2 or 3 watts, and it's no matter how good a speaker you put on the end of it, it's still not going to sound that great. Would you buy a home stereo that had a 3-watt output? I don't think so. These have, I don't know, I've seen all kinds of claims, and I don't know if it's RMS or peak to peak. They got a hefty little amplifier in them. Actually, only this one speaker has the amp in it. The second speaker is just a slave. The amplifier here has 2 channels. You can actually buy one. I've seen them for around $175, but $25 more to get both of them. But like I said, Bob Howe recommends these. I found them before I realized he would recommend them. But all the speakers I looked at, a near-field monitor can run you $500–600 to $1,000 and up. This is the only reasonably priced monitor that I found that has a good sound. And you can tell, one of the ways of judging a speaker is just pick it up. How heavy is it? It's a little lightweight, toss-around box. It's probably not going to sound good. It's going to resonate. These got a hefty polypropylene or whatever cast case. I've heard these compared to, you remember the realistic Optimus speakers? These little cast aluminum boxes. People are still selling those things on rebuilt on eBay for hundreds of dollars because it's the best sounded little speaker that you've ever heard. People compare them to those speakers. But they've got an amplifier, and the Optimus didn't. Okay, that concludes the yakking part. Now I'm going to go down here and try to do something. I recorded some RF on 40 meters the other night. Let's see.
Noted that the propagation opened the lead 10 minutes for our friend in South. Calling CQ40, beaming Asia, beaming the long path Japan Alpha from Victor Alpha 2 Alpha Mike. Victor Alpha 2 Alpha Mike, beaming long path and standing by. Calling CQ40, beaming Asia, long path. Calling 40 meter, beaming long path Asia, Japan Alpha long path. Africa from Victor Alpha.
Of course, with this strong signal, we're not having any problem understanding him. See if I can find something weaker.
One location where yesterday -20. Kilo 4, Zulu Oceans, good evening. Thank you very much for the call. 549, good copy. Into London, Ontario. Echo there, Zulu Echo November. So we'll pass it back to you, see how you copy, over.
Here we go. This guy we can barely understand.
Joe, if you were closer, I would buy you a boat for the price report. Thank you very much.
You can hear what these mid-ranges do. Now, this scale is not calibrated, but this is around 25 to 3,000 hertz, what you would get on a mid-range adjustment on a mixer.
Joe, thank you very much. But you have also good signal, so we appreciate it. I hear a lot of station calling, so I'm going to have to make it quick,
So
Joe.
here's without,
Thank you for the call. I wish you all the best for 218.
and it's with.
Good luck, health, and prosperity.
A little more harsh, but you can understand him better.
Many times, and I hope I get many reports like you give me today, Joe. On November 4, Zulu Ocean, Victor America 3 Sugar Zulu. Good evening, Joe.
On this type of mixer, I can actually change the width of the filter. I spread it out. Let's see. One thing that's not showing here. Uh-oh. Did I come to the end? Shoot.
Because, you know, ups and downs, the 40 meters was very, very miserable, you know, but, you know, weather and propagation we cannot choose. Whatever's come, we have to live with it. Sir, thanks for the call. Good luck to you. 73 and all the best, and I'm sure we'll meet again soon.
Now we can actually see his
Lima, Bravo, India.
signal,
America 3 Sugar Zulu,
where he's
73.
peaking at.
Calling CQ40, CQ40. Victor, America 3 Sugar Zulu, calling 40 and standing by.
See, we're cutting off right in here.
Zulu, November 0, Alpha Victor Radio. November 0, Alpha Victor Radio. Good evening, sir. Thank you for the call. Nice signal, 59 plus 5. Excellent copy.
And that is about 3K.
Hello, Red.
So,
Zulu, Echo November. Back to you, copy. Very good, son. You're 10 over.
At least for this recording, you know, you're flat hit a brick wall at 3K. There's no audio above that. So we were just making an adjustment down here with, say, a triple control. It would hardly touch the signal. Or if I was down here in the low frequencies, where a bass control would be, not a darn thing. That's why you need a mid-range. And that's a little wider than normal. Good tip. So you can really sharpen him up right there. A little harsh on the ear. But you can really hear him cleanly. Can't hear who he's talking to. It's the ALC in the playback that's causing the volume to go up and down. It's set to slow. Now with this mixer, you've even got more. You got more you can raise and lower. And you can get all crazy with it. But there's no real need for that in this environment. You can see where most of the signal and most of the noise is coming from.
Thank you very much for 59. Thank you
See,
very
his
much.
voice is peaking right there.
Back here. But anyway, we appreciate the call. I hope we meet again in better condition. Hopefully the band will improve you no farther into a spring. 73 all the best.
Turn it off.
My friend. Kilo German 4, Golf Tango Delta.
Turn it on.
Victor America 3 Sugar Zulu, good evening.
Much, much cleaner, especially to my ears. Before I got these new hearing aids, I have a hard time with it. Yeah.
You were given price points before. At what price point does the digital control from the PC kick in?
Oh, that is free software with any of those. They have 3 of these, what they call XR mixers. They have the basic one I showed you, the 12 channel, they have a 14, and this is a 16 channel.
But those were the like $400 ones?
This one's around 400. Yeah.
What's this, is this a Behringer?
Yeah, this is a Behringer XR 16, the console version. They make a rack mount version of this one as well that doesn't have the little console. Actually, the rack mount version costs a little more for some reason. I like this version. I just like saving money. So.
Hey Rick.
Yeah.
Can you recommend a way to switch if you've got a good headset, how would you manage that between multiple
Well,
radios?
here you go. My headset's already plugged up here, and all I have to do is,
No, we can't hear it.
you'll see it come up over there.
The other microphone.
Yeah. Uh-oh, reconnect, something happened here. I lost connection. Connect. Hold on one second, I lost connection here. I messed around with it and picked it up. This microphone is already live. This one right here.
Don't hear you.
I'm not. The headset microphone. Yeah, tapping it right there. That's it. Channel number 3. Yeah. It's picking, this mic is still picking me up a little bit here. Actually, I think it's picking up the speaker too.
Hey, David, touch the screen and turn it up and down.
But normally I have that when, well, I'm trying to show this and it doesn't show up. I would normally mute. Normally, mic 2 and 3 are always muted. And mic 1 is always working.
Boom mic, that's my headset.
Yeah, but down at the bottom, it's not showing. Oh, you can see it, barely see it. Yeah, you see that?
Mute.
When that mute turns red, that means it's off. So I would turn off. I'm sorry, for some reason, this thing is not staying connected. Let me give it another second. I can do it on this up here.
Okay, so there's not an impedance matching issue between the headsets and the board? Or is there any kind of impedance matching you have to do between the headset and the board, or are they automatic?
Yep, no problem. The inputs on this
Microphone.
Inputs on this mixer automatically detect if it's balanced or unbalanced and make adjustments for that. And yeah, that Heil headset with the micro, the small phone jack connectors, I just put an adapter in, jacked it right in, and turned it on and plugged the headset into the headset output. And to make that work in operation, all I have to do is unmute it. I need to make that a little smaller, that's the problem. There we go. I think, no, now cut it off. I'm having a hard time dealing with this size here. Standard size, can I get rid of that? Do lock taskbar. I want to get rid of the taskbar. Anyway, I can't get to that mute button. Yeah. Oh. That's what I was trying to turn on. Always hide labels. Taskbar on screen on bottom.
If you right click on the bottom taskbar, you can make it hide.
Yeah, he's there, but it's on.
Right click, I did. It wasn't there.
The other right click.
taskbar, with windows open. Labels. I'm sorry, I'll make it simple though, as I can. We'll just go back up full size. Hiding underneath the taskbar, there's a mute button. So I got both mics plugged in, they're live into the mixer. But what I would do, if I wanted to use my headset, I'd just mute my desktop mic by clicking the invisible button down here and unclick my my headset mic, run its thing up there. Oh, yeah, run it, it's already up. And then I just hit solo. Whatever I hit solo, I have it rigged up so that this goes into the radio. And when it's off, it's just normal. Anything I hit on solo, normally by default, the desktop mic always goes to the radios. But if I want something else to go to the input of the radio, like computer output for digital, I'll just click solo on the computer. And these two channels are linked as a stereo channel. So when I click one, they both come on. That's the analog. I also have the computer connected digitally, so I can choose to output digital from the computer. And this mixing board shows up as a USB device when it's plugged into your computer. So like I said, there's lots of kind of stuff to get lost in here. Believe me. Not all showing up the way I like. Oh, there we go. Compression. You can not only control how much compression, but how long an envelope of gain there is. Side chain filter, I could set it so when I talked it would mute something else. There's a lot of things that are used in the professional world that you'll probably never use. Sends, I can tell what bus to go to where. Oh gosh, what else? There's all kinds of effects, which we're not even going to talk about that. And there's a nice little meter pound here where you can get all the little meters going.
I assume that's really all PSP, there's no real audio in there.
Well, yeah, right. It's all DSP controlled. Yeah. Your analog signals go in, get immediately turned to digital, processed by a DSP controller, and then turned back to analog, spit back right out. So, anyway, now that I've thoroughly confused everybody, here's one that is cool. Is that it doesn't matter what you have plugged in to what button, what jack, you can change it. I said, oh, I want channel 2 to come out on 3. You can just change it without changing the wires. Like I said, there's a lot that can be done. A lot you don't need, a whole lot. But I'm a gadget freak. I like messing around with it. I know a lot of people do. A lot of the reasons some of us are in here are to do that. Have I wasted enough time?
Yeah.
No.
Okay. Thank you very much.